In this video, I'm going to go over how you can facilitate the synthesis of the Explorer for Lesson 12A, Completing the Square Part 1, Unit 7, Day 22. The focus question of this lesson is how can we write perfect squares to help us solve quadratic equations? By facilitating the synthesis in this type of conversation, students are going to have a chance to solidify their understanding of completing the square, which is going to support them in future lessons when they are continuing to complete the square. So I'm going to jump down to the Explorer. You should give students some time to work on this either independently or preferably in partners in breakout rooms, giving them a chance to really think through this section. The top 3 questions should be a review for students based on stuff we've been doing, but they're all perfect square trinomials, so it's just going to get them to start thinking about some patterns that exist. And then they're going to come down here and really think about how they can find these missing values using their reasoning skills. So students have time to work on this independently. You come back together, and to facilitate a conversation, you first can have students share out some of their responses. So for the first one, we write it in factored form. Some students might have said they're going to write it as x plus 3 times x plus 3. How can we rewrite that in another equivalent way? X plus 3 raised to the second power. Right? Any number times itself or any expression times itself is just another way to show that it's being squared. Exponents are repeated multiplication. Same thing here. We have x minus 5 raised to the second power. We can ask students, how did you know it was in minus here? Because that middle term was a negative. What's the relationship between this constant in the factored form and the constant in the standard form? It's that squared. What's the x's relationship in factored form and standard form? That's also squared. And how do we get this middle term? Well, it's these two numbers multiplied and doubled. Right, so asking them those questions here is going to support them as we come down here. For this one, right, same thing. Well, we know it's going to be x squared based on what we just said, and we know the last term is going to be a positive 49. What's the middle term? Well, the middle term is minus 14x, because this negative 7 times x is negative 7x, and we're doubling it. And so we want students to start seeing that connection. So now we're going to come down here and we're going to ask students, okay, how did you know what to fill in the blank? Well, I knew that if we're talking about perfect square trinomials, I know that I have to find two numbers that are the same that add up to negative 20. And I know that those two numbers that add up to negative 20 that are the same are negative 10 and negative 10. So I did negative 20 divided by 2 and got negative 10 and then multiplied it by itself. I squared it and I got 100. Right? And so students might not articulate all of that, but you can ask them guiding questions. If they give you the answer and they say, okay, I put negative 10 here and 100 here, how did you know that was going to be a negative 10? They should have been able to articulate that they found two numbers that are the same that add up to negative 20. And how did you know that was 100? Well, I knew that they had to multiply those and square that number to get to the last term. Okay, same thing here. I had to find two numbers that are the same that add up to 16, and those two numbers are 8. So I know that goes here, and I know that 8 times 8 is 64. I had to find two numbers that are the same that add up to 7. Well, in order to find those two numbers, what did you do? I divided 7 by 2 and I got 3.5, or we can write it as a fraction. And then what did you do to find this? Well, I knew I had to square that or multiply it by itself. So 7 times 7 is 49. 2 times 2 is 4, so 49/4. For the last one, I had to find two numbers are the same that add up to b. Well, how do I represent that? And this one is going to be really hard for a lot of students. Two numbers that are the same that add up to b. Well, what's the relationship between 7 and 7/2, or 16 and 8, or 20 and 10? Divided by 2. So b divided by 2. And what's the relationship between negative 10 and 100, or negative 7 and 49? Well, they're squared, so I'm going to square that here. And again, this one is going to be the trickiest. So now we want to use color to really annotate and show connections. So you're going to choose an example from the table, and you're going to highlight the coefficient of the linear term in the standard form and label it n. So let me get the highlighter. Let's just look at this one right here. The linear term in standard form. The linear term in standard form. And I'm going to label that n. I'm using the same color. Then I'm going to highlight the constant term in standard form and label it as n divided by 2 squared. So I'm going to choose a different color to highlight. Oops, I want to use a different color. And then I'm going to label this as n divided by 2 squared. And then I'm going to write n over 2 to represent this negative 10 here. And choose a different color, maybe pink. And using color is a way, especially to help students who are maybe more visual learners. I'm going to write n over 2. And this is a way, so I'm going to annotate this way and I'm going to show the connection, right? So we know if this is n, we divided it by 2, negative 20 divided by 2, and that gave us our factored form constant. And then we took that and we squared it to find our constant in our standard form. Or maybe some students might have said, well, I knew that the relationship here is you take half of that and you square it to get here, or half of that and you square it to get here. So half of this n squared gets me this term. Either way they worked it out, we still are able to see these connections using these annotations. So then what you can do next is you can ask students to select and annotate another from the example from the table to show their understanding. And you can either do this on another platform to be able to check, or you can have them do it on Google Docs using the Google Docs features if you would prefer, so you can actually check their work for understanding. And again, so n divided by 2 squared, and then this term is n divided by 2. And by annotating this and starting to internalize this, this is getting them ready to complete the square in future lessons. So in summary, it is really important to give students a chance to really synthesize their understanding by reviewing the Explore portion of this lesson and using color annotations to point out the key connections between the different terms within standard and factored form for perfect square trinomials.